Hey guys, it's Mr. Walker here, and welcome to another math lesson with Mr. Walker. Now, I'm super excited, super stoked again today. I know I'm excited about math every day. I kind of it kind of gets old after a while, right? But I am excited about today because today we are talking about one of my favorite things in the world, shakes, right? Who doesn't love a shake? Now, personally, I am a big favorite of vanilla, like plain old vanilla shake. I think even if you can get some French fries to dip in it and eat it that way, I think those are great. That's not to say I wouldn't turn down like a cookies and cream or even a chocolate shake. I mean, you can't really go wrong when you have a shake. Oh, hang on one second. Producer's talking to me here. Right. Oh, this is a math class. Yeah. Oh, shapes with a P, not a K. Right. Yeah, I thought it was kind of weird to be talking about shakes in a fifth grade math class, but okay. Yep, my mistake. All right, guys, sorry about that. So evidently, I did not do my close and careful reading when I was looking over my lesson last night, and we're talking about shapes today, not shakes, although I could really go for a shake right now. It's kind of depressing. Anyway, we're talking about shapes, right? So this is good because we've actually been talking about this for a few lessons now, so we're kind of getting into the swing of things, and you guys are becoming shape experts. You're really shaping up, if you will. Oh, jeez. But we're going to keep moving forward with that and still keep learning how we can categorize different shapes and organize shapes by their attributes and the characteristics and things like that. And today we're going to be looking into looking at rectangles and rhombuses, okay, to clarify what their attributes are, what we're looking for, what makes a rectangle and a rhombus, defining those things, and even maybe creating some of our own. Okay, so we got a couple different things going on today. So I wanted to start by having us just kind of review some terms and things like that, and then we'll get into the actual building and drawing of shapes. So before we get into that, let's make sure that we have something to write on, something to write with. We're definitely going to need, if you have like a ruler, we're going to be using our ruler again today. Have some paper that you can draw some shapes out on. A protractor would be really handy if you have a protractor, and if you have some sort of like square kind of thing like this is how it can help to make like parallel lines. I can line up against here and here. It's not necessary. You could also just use like the edge of a piece of paper. You just want something that'll give you like a 90-degree angle would be kind of nice. So if you're fancy enough and have something like this, cool. If not, like, don't stress. Don't go out and buy one. They are helpful, but not necessary. So if you have those things, you're ready to go. Gather up your protractor, your ruler, something to write on, something to write with. Have those things be ready to go, and then we'll start off by talking about the hierarchy of quadrilaterals and what exactly a hierarchy is. All right, so get those things, guys, and then click continue, and we'll keep going. All right, guys, so let's start off. I made a handy little chart thing here about the hierarchy of quadrilaterals, and we know what a quadrilateral is, so that's not a new vocabulary term for us, but hierarchy might be something that's kind of new. And a hierarchy is not necessarily a math term, it's just kind of like a general term. And what it means is, oh, almost forgot.
Math vocabulary.
And what it means is kind of like the ranking order of something, okay? So the hierarchy of like a food chain would be like the thing that eats everything is at the top, and then you kind of work your way down by the like if you had a bear at the top, and then a fish, and then the bugs, and then the algae, and things like that. That's the hierarchy. It's kind of like the order of things. It's the way you can kind of set up things and categorize things, if you will. So we're going to take a look at the hierarchy of quadrilaterals because, yes, even these shapes, these two-dimensional shapes that we've been looking at, they have a hierarchy as well. So if we start off here with quadrilaterals, that's kind of like our big encompassing everything, okay? As long as it's a two-dimensional shape, that means a flat shape that has four sides, right? Remember, four sides, quadrilateral. We can break that into another category of trapezoids, okay? So we have trapezoids, which fits inside a quadrilateral. So all trapezoids are quadrilaterals because a trapezoid has to have at least four sides, and it has to have, trapezoid has to have four sides, exactly, and it has to have at least one pair of parallel sides, okay? So that shape has to have at least one pair of parallel sides. And we took a look at trapezoids in some previous lessons. Inside of trapezoids, there's another category that fits inside that. So this category is not only a quadrilateral, not only a trapezoid, but it's also a parallelogram, okay? So this one is a quadrilateral where both sides are parallel. Both of the opposite sides are parallel, okay? So a trapezoid has at least one pair that's parallel, a parallelogram has two pairs of sides that are parallel. Okay? Today we're going to go even further into some other categories, which are going to include or be within the parallelogram kind of circle here. So not only are they going to be parallelograms, not only are they going to be trapezoids, not only are they going to be quadrilaterals, they're going to be all of those things, but even more specifically, we're going to be taking a look at rectangles, and we're going to take a look at rhombuses or rhombi. Either way is the plural of a rhombus. Okay, rhombus is one, rhombi is two, rhombuses is two or more. Rhombi to me always sounds like the villain that you might face in like a video game or something like that. Like, I am rhombi, I crush you like a bug, something like that, right? So we're going to take a look at rectangles and rhombuses or rhombi. And a rectangle, as we'll see in a minute, is a quadrilateral, so it has four sides, and it has four right angles, okay? So the angles in there have to be right angles, which means they measure 90 degrees. And a rhombus is a quadrilateral with all of the sides that have the equal length. So the angles don't have to be any specific way, but the sides have to be a specific length. They have to be an equal length, okay? So we're going to take a detailed look at what more of these are, kind of be able to identify them and organize them. But that's kind of like the hierarchy of these shapes. And we're also going to get into square a little bit in this lesson, and more so in the next lesson, and what a square is, even though most of us pretty much know what that is. All right? So that's kind of our hierarchy of quadrilaterals, okay? You have your two-dimensional shapes that have four sides. Then you break it down to trapezoids, where at least one of the sides are parallel. Parallelograms, both of them are parallel. Then you have your rectangles and rhombi or rhombus that we're going to go over more in depth today. All right? So hopefully that's making sense. This is one graphic organizer that I kind of made that I'll share, but there's also ones available in the module as well that kind of help to lay this out in a different way and actually use the shapes to lay it out, so you guys can take a look at those as well. But it's just kind of important to know how these shapes kind of interact with one another, okay? So let's get in, let's start drawing some rectangles and some rhombuses, or some rhombi, if you will, all right? Alright guys, so I'm going to try something out here. I'm going to keep this sheet here that I'm going to draw on. I'm going to keep that up. I'm also going to keep the hierarchy of our quadrilaterals, that little graphic organizer that I made. I'm going to keep that up as well so we can refer to it and kind of use it as we start to draw some of these shapes, okay? Now, a rectangle right off the bat, I think most of us can draw a rectangle. We recognize it, but we're gonna get to that in a second. So I'm going to start with the rhombi, the rhombuses, and take a look at how we could draw them. Now, first of all, we have to start by drawing a quadrilateral, right? And a quadrilateral it's going to have four sides to it, right? So if I were to draw a quadrilateral, okay, it would have four sides. Perfect. Now, if we're going to get to that rhombus there at the bottom in the middle there's a couple other things that we're going to need to consider though as well. A rhombus also has to be a trapezoid. It also has to be a parallelogram, okay? And then the specific definition for a rhombus is that it has to have sides that are all the same length. So I could start here just like willy-nilly and start to figure this out and be like, okay, well, but this side's, they look parallel, so at least that's good, but this side looks a little bit longer than this side, so let me make sure that I'm making this square. And to make sure that I'm getting this right, this is where my ruler can come in, right? So I could come here and I could draw, let's see, I'm going to go with 3 centimeters here. And then I can measure up, because all my sides need to be the same length, right? So I can measure up 3 centimeters here. And I can measure up 3 centimeters just to make sure I have like a parallel line. Kind of draw that across here. So now that's good. Now, a rhombus doesn't have to have any particular angles to it, right? It doesn't say anything about angles, just that my sides are the same length and that they're parallel, because that would be the category from the parallelogram. And then, you know, at least one side's parallel, which would be the trapezoid, and it needs 4 sides because it's a quadrilateral. So let me see if I do this here. Put my 3 here. And I could really kind of draw this like that. And come down here. Could put this in here. There we go. Okay, so I know I kind of overlapped my lines a little bit, but it still will work. Okay, so I could just measure and say, okay, well that's 3. That's 3. It's a little bit less than 3, but I could fix that if I needed to. But my angles don't have to be any certain angles in there, so that's okay. So this is a rhombus, which is also a parallelogram, which is also a trapezoid, which is also a quadrilateral. So you can see that it kind of fits into all those categories, but the most kind of specific category we can get to is a rhombus. Okay, let's let me do this. I'm gonna flip this over and come to the back. Let's look at another way that we can draw a rhombus to make sure that we're doing things right. So this one I'm gonna draw just a little bit bigger so we can see it. This guy I'm gonna draw at 10. Okay, so I'm gonna draw 10 centimeters here. And what I'm going to do is I'm just going to start by drawing an angle, because we know that, you know, the angle can be any angle. It doesn't have to be 90 degrees or anything like that. So I'm going to draw this one a little bit more drastic of an angle here. So let's say I'm going to find my end point, okay, right here, and then I'm just going to draw this. This has to be 10, right, because it has to match my other line. So now I have an angle here of 10, and we can kind of think of this as, let's say we'll do this as A, B, C. Now, those are two sides, but I need two more sides, right? Can't just leave this way. All right, so next I have my angle here. I'm going to have to draw another side. I'm going to have to make it parallel, so either here or here. So I'm going to go ahead and draw like this line going up here to make it parallel. If I want to check to make sure that it's really parallel, what I could do is using another piece of paper, which I have here, for like kind of like another straight edge, if you will, I'm going to just measure over that 10 centimeters and kind of line up that piece of paper with my end point here. Okay, and then I just want to make sure that it's like 10 centimeters and 10, so I got to angle it out just a little bit more just to kind of check. That's about 10 centimeters all the way. Now, we're not like graphic artists or anything like that. You know, we're just looking for as accurate as we can be. So like this one, if I line up my 0 over here, for the most part, we're hitting the 10 centimeter mark, like right out here. The camera's a little unbalanced, so let's try. It looks a little bit better that way. Okay, so that's kind of what we're looking for. Okay, doesn't have to be perfect, but you're looking to try to make it as even as possible. So now I could just use this as like my straight edge, kind of, and draw through here. Okay, so now I have that line that looks parallel to me, and then I can simply come through here, line up that line and that point A, and there we go. Now I've added in point D here. Okay, so I have my rhombus now. I have 4 sides that should all measure 10 centimeters, so let's just double check. Got 10 there, good. Survey says 10 there as well, perfect. Over here we're looking at 10, awesome, and over here we've got 10 as well. So we have a rhombus, all right? The angles don't matter for this one. They don't have to be a certain distance. I mean, they do matter. It makes up the shape. But they don't have to be a specific distance in order for this to be a rhombus. But what we are going to know, or what we should remember, is that the angles that are next to each other, like these two angles here, they should add up to 180 degrees. Same for those two or those two. And all of the angles together should add up to 360 degrees, because that's what we've seen in all of the other shapes, all of the other quadrilaterals that we've drawn so far. Alright, so now I'm going to take my ruler. I want you guys to do the same. If you haven't drawn a rhombus yet, man, get on it. Let's do this. Take a second, draw yourself a rhombus. Make sure that all of the sides are equal. It doesn't matter if it looks like mine or if it looks a little bit different, as long as all of your sides are equal and you have 4 of them. So go ahead and do that. Equal sides, parallel sides, because it's also a parallelogram, and 4 sides because it's quadrilateral. So make sure you have that, and when you have that, click continue and we'll keep going. Alright, sweet. So the next thing I'm going to do is I'm going to draw the diagonals on this rhombus, just to kind of see it, just another way to just look at this and see what we have going here. Okay, so let's do this now. We're going to go from point B to point D. Okay, B to D. I'm just going to draw a line across those. Okay, so that's my diagonal point, and I'm going to do another one going the other way from A to C to shining C. Let's do this here. There we go, perfect. So now I have those lines that intersect across the middle there. They are the diagonals. They bisect each other. Okay, this is like our bisect point, middle point. Okay, so if you hear that term bisect, that's what they mean. Would help if I spelt it right though. Sheesh. And there we go. This is the midpoint again of our diagonals. Okay. Now let's look at this for a second. What do you notice about these angles here, where these diagonals cross? What do you notice about these angles as opposed to like our angles that we had out here? Ah, they're 90 degrees, aren't they? They are 90-degree angles. Ah, they're 90 degrees, aren't they? If I take this piece of paper and put it in there. Look at that. That is a 90-degree angle. Interesting. And same for this guy, same for the other guys. It's a 90-degree angle. So that's pretty cool. Then in the rhombus, our angles are going to add up to 90 degrees. There's actually a special name for this. Because they intersect at that 90-degree angle like that, we call these a perpendicular bisector. Perpendicular is when something crosses at 90 degrees, okay? So, again, just to review, what is something that we need? What is a characteristic or an attribute we need in order for this parallelogram here to be a rhombus? Because right now it's a parallelogram, but what else about it makes it a rhombus? Exactly, all the sides are equal. They're all the same length. That's what makes it a rhombus, okay? Cool. All right, let's move on to rectangles, right? Let's do this. It's rectangle time, it's rectangle time. There's not really a good rectangle song out there, so we'll have to make one up. See if you guys come up with one. So here we go. Rectangles. According to our hierarchy here, a rectangle is a quadrilateral, so it's going to have 4 sides. It's going to have sides that are parallel, at least one side that's parallel, which makes it a trapezoid. It's actually going to have 2 sides that are parallel, which makes it a parallelogram. And according to the definition that we went over earlier, it's going to have 90-degree angles. That means all of our lines are going to be 90-degree angles, okay? So if I want to draw a parallelogram that is also a rectangle, I need those 90-degree angles. So if I wanted to do that, and I could come down here, let's draw a bigger rectangle again this time. I like that 10 centimeters. That's a big. So I'm going to draw a straight line here, and then the next line that I draw on either side, it needs to be 90 degrees. So if I wanted to be sure, I could use my triangle thing here, because I could line it up along the bottom line, and then I know that this line, as long as it's lined up straight here, this line going up the side, it's going to be 90 degrees. Okay, perfect. I could also use a piece of paper and just put that piece of paper the same sort of way. Line it up along the bottom here, and then trace up the other side of that paper. There we go, and there's my rectangle, and then I could just close this one off at the top here. Now, in the rhombus, all of our sides had to be the same length. Is that true for a rectangle? No, it doesn't have to be. So this could be 10 going across the bottom here, but this could be a different length, and let's see what this length is. It's only 8, and that's okay, okay? Once we get into squares, you're going to see where that length matters, but for rectangles, it doesn't. As long as my sides are parallel, which makes it a parallelogram, and if all of these angles are 90-degree angles, then we have a rectangle, okay? Which they are, because we used our tools to help us do that. We do want to make sure, though, that these opposite sides are the same length. So this side has to be the same length as this side, and this side has to be the same length as this side. If they weren't, what would happen is you wouldn't have a rectangle anymore, because our angles would be different. It would have to be tilted one way or the other, and those angles wouldn't be 90 degrees anymore, okay? So what we're going to do next is we're going to cut this out, because we're going to look at a couple different things about this rectangle, and cutting it out is going to make it a little bit easier to do that. All right, here's my rectangle. A rectangle. Boom, boom. We'll get there. Okay, so if we wanted to kind of just like check the lengths and things like that, and that this is indeed 90, like we could kind of fold it in half, and okay, our opposite sides, our lengths match there, our lengths match there. That's awesome. So that would be one way to kind of like take this and kind of visualize that, what we're seeing there. But let's go ahead and do this first. Let's measure our diagonals here. Let me get my centimeters going again. So I'm going to measure from this point here across to this point, and then I'm going to do the same thing on this side. Okay, so from this guy to this guy, it looks like we have, let's just see here, it's like about 13, okay, 13, and then if we measure this way, would you look at that, 13, okay, and that's because of the way that the the rectangle lays out with those 90 degrees and those sides that are the same length, opposite sides that are the same length. So if we drew those lines across the middle here, do you think that's going to be a perpendicular bisection, a perpendicular bisectors there? Are they going to be 90-degree angles in the middle there where they meet? Why or why not? No, they're not going to be, because they're not going to form those right angles, right? If we just kind of drew this in here, let me just draw them in real quick. Bear with me, talk amongst yourself for a second, maybe hum a little tune. Yeah, da, 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 da. I'm drawing line bisectors across my rectangle. There we go. Alright, So these are not going to be 90-degree angles, which means they're not perpendicular bisectors, okay? So just another kind of characteristic or trait that we can keep in mind when we're seeing rectangles, just to kind of know like what we're looking at and what it means. So I think I've spent enough time with you guys drawing shapes and looking at rhombuses, rhombi, and rectangles. I think we're starting to get the hang of what they are, what their certain attributes are. So you guys are going to play around with them a little bit more today. You're going to practice making some stuff, recognizing some shapes and things like that. So as always, reach out if you have any questions, comments, or concerns. There's a ton of information out there about shapes that I'd be more than happy to share with you guys if you need it. But good luck sorting your quadrilaterals, especially your rectangles and your rhombi. And let me know if you need anything, guys, and have some fun, all right? I'll talk to you soon. Thanks.